Here's my data. Here's my labeled axes here, my y-axis or my input axis, y being the year since 2000, and the output axis here is the value of the car in thousands of dollars. So that looks like a pretty good scaling. It used all of the grid here. So notice I've labeled my points. Notice those guys fall in a straight line there. And so let's go to after this next question here. What is the slope of a line containing the points? Now you could probably draw a line in there, but I'm just going to say what's the slope of that line, and then we'll talk about what it means here later. Well, let's go back to original definition here. One of them is numerically the slope is calculated by the change in output divided by the change in input. So really we have this. The slope is divided by the change in output. That simply means change in divided by the change in input. For us, we could use variables here. The change in V divided by the change in Y. So I'm going to write that here. Change in V divided by the change in Y. So the question now is, which pair of points do we use? Well, I want you to see here that this is consistent. This slope is consistent over any pair of points we use, so it doesn't matter what pair of points that we use here. Apparently, anyway, let's look at these. So let's look at the first pair. If we find the slope of the line here between these 2 points, we would take that minus that. That's the difference of the output variable V, divided by 5 minus 2, the difference or the change here in that. So I'm going to write 23 minus 32 over 5 minus 2. Alright, so there's my slope value we're going to give. So that's a negative 9 over 3 or negative 3. So the slope of a line here, it's a numerical value that describes to us the relationship between V and Y. And so what we're going to do in our next video is talk about what that is. What does this tell us about the relationship between Y and V in this situation?